All right, science detectives, welcome. Today, we're on a mission to crack a case, and it's something you literally see, eat, and breathe every single day. So get your lab coats ready, because we're about to dive into the jumbled up world of mixtures. So, let's kick things off with a little puzzle. What could a bowl of cereal, a fizzy glass of soda, and the very air that we're breathing right now, what could they possibly have in common? I mean, think about it. What's the secret connection here? If you guessed mixtures, you are absolutely right. Our world is just packed with them. Seriously, from the stainless steel fork you eat with to the soil in a garden, things are constantly being mixed together. So today, our mission is to really understand what they are, and even cooler, how to take them apart. So what is a mixture exactly? Well, think of it like a party. You've got a bunch of different things all hanging out in the same room. They're all together, sure, but they haven't changed into something totally new. They're just physically mixed. Okay, let's really dig into this because this is super important. You've got to know that mixtures are not the same as compounds. A mixture, think of it like a fruit salad. You can still see the strawberries, you can still taste the blueberries. They're all just hanging out together. But a compound, that's more like a cake. Once you've baked it, the flour, eggs, and sugar have gone through a chemical reaction. They've become something brand new. You can't just pick the eggs back out of the cake, right? So now that we've got a handle on what a mixture is, let's learn how to spot the two main types you're going to run into out in the wild. This is how we'll classify our evidence, detective. We can basically sort our mixture suspects into two groups, smooth or chunky. Now, the scientific term for the smooth ones is homogeneous, and for the chunky ones, it's heterogeneous. Really, it all just comes down to whether or not you can see the different ingredients. Okay, so homogeneous mixtures are these masterfully blended things. You know, like when you dissolve salt in water. You can't see the little salt bits anymore, can you? It all just looks like one thing. Or the air around us. It's a mix of nitrogen, oxygen, and other gases, but it all looks perfectly clear. Even something solid like stainless steel is a smooth mixture of iron and other elements that stop it from rusting. And then you've got the other side of the coin, heterogeneous mixtures. These are the ones where you can easily spot all the different parts. You know, like a bowl of cereal and milk, or when you see oil floating on top of water. The parts are not evenly mixed at all, and you can totally see where one thing ends and the other begins. Fantastic work, detective. Now you can identify any mixture that comes your way. So it's time to open up that special toolkit of ours. Let's learn how to separate these mixtures back into their original parts. Let's look at our first case file. Oh no, we've got two different solids all mixed up, tiny iron filings and sand. How in the world are we going to sort this mess out? I mean, we can't just pick out every single grain by hand. You know, the trick here is to find a unique property that affects one of these things, but not the other. And in this case, we are in luck. Iron has this really cool property. It's magnetic. So a magnet is the perfect tool for this job. And just like that, it works. See? All we did was use one of iron's unique physical properties, the fact that it's magnetic, to literally yank it right out of the mixture. How cool is that? All right, let's move on to our next challenge. Here, the difference isn't magnetism. Nope, both flour and pebbles are non-magnetic. So what physical property can we use to separate them? Just think about it for a second. What's the most obvious difference between a pebble and a speck of flour? This time, the key difference is just their size. And for this, all we need is a super simple tool, a sieve. So sieving is absolutely perfect for separating solids that are different sizes. And this technique gets used all the time, from bakers sifting flour in a kitchen to construction workers separating sand from gravel on a building site. Okay, this is a classic survival scenario, right? We've got a liquid, water, with an insoluble solid mixed right in. Insoluble just means it doesn't dissolve, like mud or chalk. And we definitely do not want to drink that. So, to solve this one, we need a special kind of barrier. We need something that'll let the liquid pass right through, but will trap all those solid particles. We need a filter. And this whole process is called filtration. It's an incredibly important technique. It's used in everything from the water purifiers you might have in your house to these gigantic water treatment plants all over the world. Now for a totally different kind of challenge. Here, the solid, the salt, is dissolved in the liquid. We can't even see it, and the particles are so tiny they would just pass right through a filter. So what's the plan now? For this tricky case, we're going to use the power of heat. See, water and salt act very differently when they get hot, and we can use that difference to our advantage with a process called evaporation. That process of a liquid turning into a gas is called evaporation. So, yeah, we lost the water, but hey, we recovered the salt. And this is exactly how sea salt is harvested from the ocean. Excellent work, detective. You have successfully identified all the different types of mixtures, and you've solved every single separation case we could throw at you. So let's wrap this all up with a final mission debrief. Okay, here's the quick summary, your final report. Just remember these 4 key things. Mixtures are just physically combined. They can be smooth or chunky. We can separate them by using their unique properties as clues. And finally, they are absolutely everywhere. And the most amazing thing is, this isn't just something you learn about for a test. Now you get to look at your world with new eyes. The science of mixtures is all around you, from a muddy puddle to a cup of hot chocolate, just waiting for you to explore it. So keep asking questions and keep investigating.